Alright guys, this is from page 81 in your book, and you got number 20 through 30 up here, and you had the even ones, so I wanted to run through those with you. They ask you to do a few things on here. First, identify the parent function. I think we're okay with that if you look at a few of them here. For instance, number 20, number 26, number 24, those all have some version of a parabola in them. They're all in vertex form of a parabola, which makes it easy to identify transformations. But the parent function for all of those would be f of x equals x squared. If you look at 22 and 30, those both have something cubed in them, so they're going to end up being a cubic equation, which the parent function would be f of x equals x cubed. And finally on 28, that's got something in a square root, an x in a square root, which means it's going to be a radical. So there's identifying the parent function for each of them that we would otherwise have to do. For part B, it asks us to describe the sequence of transformations, and that's what we're going to do first here. So we'll just look at what would the numbers in here do, because I think that's the easier part of it. So we can go through and run with this one. We're going to say the only thing that would happen is it's going to go to the right 8 units. I'm just going to say right 8 to save some time. But number 22, there's a negative in front, and this is going to make it reflect. The order of operations tells us to do parentheses. There's none here. But exponents, well, there's an exponent, but that's fine. We can't do much with it. It's just cubed. Next thing is multiplication and division. That's a -1 times x cubed right here in the front. That's going to have the effect of reflecting in the x-axis. Then finally, the last thing right here is going to tell us down 1 unit. And it happens in that order too. You wouldn't go down 1 and then reflect in the x-axis. That's going to do something different. Look at 24 down here. First of all, with the little -7 that you have on the inside, it's going to go to the right 7. That's in parentheses, so it happens first. And then the 2 on the outside, you're multiplying the output, you're doubling the output. That has the effect of stretching it vertically. If you stretch something vertically, you are multiplying by something on the outside there. So we're going to say stretched vertically by a factor of 2. And that's how that one would work. Now we go over to 26, and we're going to kind of look at that. Inside parentheses, the +10 tells me to go to the left 10. The negative out front says reflect it in the x-axis. This would be a downward opening parabola. So we have a maximum at the vertex. And then finally, up 5. So there's the transformation. 28's a little bit different. They are multiplying inside the function, inside the square root part in this case. And just like in number 26, where you had a +10, and that +10 made it go the opposite direction, this is going to affect the horizontal, but instead of shrinking it down because of the 1/4, it horizontally stretches this thing or expands it by a factor of 4. And that's the only thing that's happening in this case, so I'm assuming you'll want to talk more about that one, but it's a horizontal stretch, or I don't prefer to use stretch as much as expand, but you get the idea. Horizontal stretch by a factor of 4. You can always figure out that what that is, because it's going to be the reciprocal of what you're multiplying by on the inside there. So it's stretched by a factor of 4. It's going to have the effect of, instead of going up and over to the right, it's going to make it go up and over even further to the right before it gets up to the next value, because you're shrinking your input, which stretches it horizontally. It makes the output not grow as fast. The bottom one here is a little bit easier. You got left 3 and down 10, and that's the order in which it would go. Now what they ask us you also do, and I'll do that in blue ink on this, is to write g of x, the function that they've given, as a transformation of the parent function. So for the first one, it would have been x squared, but what they've done is they've changed the input. So g of x is going to have to equal, instead of f of x, f of the new input, x minus 8. Because it's x minus 8 squared instead of x squared. Looking at this next one here, g of x, what they've done, x cubed was the parent function. We multiplied it by -1, then subtracted 1. So we show that by saying negative f of x, that's multiplying it by -1, minus 1 at the end to show that part. On 24, you can see that the input has changed to x minus 7, so g of x is going to have to equal f of x. No, it's not. I forgot the 2 there, because we're going to multiply what was squared. The part that's squared is getting multiplied by 2. The function has an input instead of f of x, x minus 7 in this case. I'm not putting a squared on there because f of x is x squared, but we have a different input. We have an x minus 7 instead of an x for that. So on 28, we look at what happened. We went left 10, which means we had a plus 10 in parentheses. We had to multiply it by a negative, and we had to add 5. So g of x had to equal negative f of x plus 10. I've changed the input, plus 5 at the very end. And that's the function notation for this. This last one is very easy, actually. G of x equals f of 1/4 x. They've changed the input. And then finally, this one went left 3 and down 10. It would have been x cubed, but it's x plus 3 cubed. So we have to say in this case, g of x equals f of x plus 3, and then take away 10 at the end of it. So there is 20 through 30, and we've got another video after that.